Hey, Jeff.
Hey Brian, I thought I assume maybe the meeting is moved to 9.
Yeah, I didn't see a update, but it might be. So
Yeah,
yeah, I
I
might.
didn't even.
Yeah, this half hour um meeting start time has kind of been my bane for the last couple of months. There's lots of me trying to schedule on either side of it.
Yeah, I wonder why they did it, right? Because everything else seemed to be on the hour.
Uh it used to be at a different time, and then it got shifted. I think maybe because Rom was in India at the time,
Mhm.
and aren't they on like I can't remember. Maybe some. I think one of their time zones is shift, or maybe it was daylight savings got shifted a half hour, something like that.
Yeah, that rings a bell.
Hi, Atai. Just FYI, we're not.
Hi.
We were. There was a plan to move this meeting a half hour later, but
Okay.
we never got a calendar update. So I'm not
Okay.
sure. I'm not sure if the meeting got moved or not. So I'm gonna hang out and see how people join, but just know we might end up starting in 30 minutes.
So you suggest to okay? I'll stay logged in any case.
Okay,
Uh,
just FYI in case we have a long period of
okay,
silence here.
I see. So in 30 minutes you expect to start.
That is my expectation, but we'll see who joins.
Okay. Okay. Thanks.
Brian Samonis, is there any meeting tonight? Today?
Yeah, there is. It's just there was there was a request to move the meeting half an hour later, but I don't think they sent out a calendar invite. So it seems like half the people are delayed by half an hour. So I think we're just going to start in 10 minutes or so.
Okay.
Sorry, I didn't see you join, Boone. I would have told you.
I joined late. I just wondering why it's so silent.
Good morning, everyone.
Morning. Give everybody just another couple minutes to join here.
Good morning, everyone. Hope you all joined at 9 a.m. I realize the schedule hasn't been updated in the page.
It's updated as of today morning.
Okay, awesome. So
Sorry, was there
we
an email sent out? I didn't see an email on that. I mean, on the calendar itself. Or do we have to go to the page and get it?
I have to check how that happened. Maybe Kevin receives this through the distribution list. I'll double check and make sure it is all aligned for 9 a.m. Pacific time.
Yeah, Brian, I don't think the calendar syncs.
Okay. Well, I mean, I do get calendar notifications for each of the groups. I just didn't get an updated one for this group for the time change.
Right. I mean, the message that went out this morning was for the wrong time.
Yeah, but I think I need to follow up and fix it.
Yeah, I don't think.
But
it's
it seems
updated.
9 a.m. is, sorry.
Yeah, I don't think it's updated on the chart either on the OCE page.
Yeah, we kind of decided that yesterday, so it will be trickling everywhere. Thanks for checking. So we have a couple of items for today. One is on the review for the control path, or rather link layer version 2.0. The recommendation is that we send a review of the full spec. So the control path, our plan is to insert the control path as part of the link layer and ship it out as version 2.0. And it seems that is the guideline, that we ship the whole version, not just the control path.
Okay. All right. Well, it's gonna take me a little while to kind of integrate that. If we can shortcut that a little bit for if anybody, and if we know anybody with vested interest, we could send the abbreviated form to. That would be good, just so I get feedback while I'm, in case we need to make decisions while I'm integrating it. But it'll probably take a couple of weeks for me to make that an appendix. The documents aren't compatible just out of the box. So there's a couple of things that'll have to be massaged to get it in to get it into the other document.
Yeah, how about tomorrow OCE meeting? Can we ask for that? That if there is anybody that like to review it as it is before version 2.0 is available.
Okay. Yeah, I can join that.
Awesome. And then the other one was your proposal that the few slides that you shared, and would be great to go over them here as well.
Yeah. Here, I'll share those and we can talk through those real quick. I think most people have seen them, and they're all pretty mostly whoops, I keep forgetting I had to share differently. They're mostly self-explanatory. I think most people have either seen my presentation or kind of get the gist, but I'll go through that here. And then I had a conversation with Jeff and David from Ventana yesterday on this topic, and we kind of brainstormed some some topics and things to close on, and possible solutions that we can talk about as well, depending on how much time we have in this call. Okay. Oh, and before I start, actually, one quick other point of order. Couple of weeks ago, I was out and I asked if anybody had any feedback on a particular passage in the control path spec that I actually don't remember. Did you guys actually end up talking about that? Actually, you know what?
No,
Let me share that.
we
Let me share that
didn't.
before. Let me share it before I forget. Let's talk about it real quick. It should be a real quick conversation here. Oh, sorry, one second. Yeah, okay. So we have a lot of flexibility in the control path in how you map the registers and stuff, and that you can have a mismatched number of main band and side bands technically the way that we have it designed, but I wanted to make sure that we captured what the intent was here. And so here, let me read this passage. This document specifies 3 registers for link control. The transaction link, sorry, that should be TLL. The transaction link layer and BAL specifications may list additional registers. A chiplet may support multiple main band link instances. Each main band link instance requires one set of control registers on both sides of the sideband link. Bidirectional main band communication with a partner chiplet consists of 2 uniquely identified main band links and will need 2 sets of link control registers on both sides of the sideband links. Technically, you could implement this probably with just one set of registers on both sides links handling everything, but I think the way we do references and stuff like that might get confusing. So to me, it sounds like you need one set of registers for each link, which we identify in the address space anyway, and then you need one set of registers on either side of the link for each main band. So Ram or Paul, do you guys have any comment on that?
Yeah, I mean, that sounds like what I expect.
Sorry, Brian, can you repeat?
So can you just validate what I'm saying here is right? For each main band link, you have to have a set of registers on either side of the sideband. And in the case you have a bidirectional link, that's really 2 links, and you have to have 2 sets of registers on each side of the sideband.
The sideband is, I believe, always going to be both sides, unless there are some, I think there are some use cases where you want to do it from a single side, in which case there won't be an interpreter of sort on the other side, right? So as long as so if you're talking purely on the sideband perspective, then you need a sideband message interpreter on both sides.
Right, but we need if you're having a full duplex man band link, then you need two sets on both sides, right? Because one set is for one link and one set, you have one PMR, so to say, for each main band link on both sides of the sideband, meaning there's 4 total PMRs.
Well, the PMR is only in the receiver.
I think that depends on the
That's-
implementation.
Hold on.
So-
That the PMR is only in the receiver. I don't think that's true the way we've written it, because you have to be able to send responses back, and that's sent through the partner's PMR. So even if even if the receiver is the only one sending commands, which I don't think is true either, because you can send errors and stuff, you have to be able to send responses, and responses are sent through PMR as well. So the transmitter should have a PMR as well.
Okay, so there is only one PM on each side, right? So at least the implementation that I have had, irrespective of whether the link is duplex, full duplex or half duplex, from a sideband perspective, you only need a PMR register on either side, and then you can send multiple types of messages over the same PMR. You don't need separate PMRs for that.
So you can reference multiple main band links on through the same PMR, as you're saying.
Correct.
Okay. Then I can rewrite it to reflect that. But Paul, to your point, is there some confusion on transmitters having PMRs as well?
Yeah, the PMR is a read-only register, right? In the actual implementation, you can't write the PMR from the local sideband.
Not from the local. I meant the.
So that's what I said. The
I meant
receiver.
over the sideband.
No, right. So, but I mean, again, having a transmitter PMR makes no sense then, because you can't. The transmitter can't. Right, the transmitter doesn't receive anything from the peer.
All right. Okay. I mean, I think our definitions are messed up in terms of receiver and I'm talking about main band, receiver, and transmitter.
I'm sorry. Yeah. So to me, in a bidirectional main band, right, there is only one sideband for that.
Okay.
There's one sideband per interface, per like main band interface. Per
Well,
BOW
okay. Yeah.
interface.
Well. Sideband itself is bidirectional, and so that's less of my concern. My concern is how many registers we have, right? Whether we need a set of registers for each direction. And it sounds like from Ram's discussion is we don't. You just have one PMR on one side, one PMR on the other side for a full duplex link. And you just deal with the differentiation through the addresses you put in the PMR, or the commands you put in the PMR, and make sure you're actually referencing the right link. Is your interpretation the same, Paul?
Yes.
Okay. All right. I'll edit this text because yeah, because again, the way that we've written it, I realized you could interpret it either way, the way we've defined links and stuff like that. So I just want to make sure that was clear. Okay, that was my only outstanding issue before we wrap it up. So like I said, I'll make that last version to send out, and then I will talk in the meeting tomorrow about getting some eyes on that. Let's task switch real quick here. Okay, back over these slides again. These are mostly self-explanatory, but let me walk walk through real quick. So our current transaction link layer spec is is focused on the bow phi, and its primary strength is things like SOC disaggregation. You can do, there's a bunch of other things you can do with the spec, but it requires obviously more standards to be layered on top of it. But just as it is a tool that lets you break up SOCs kind of as they are, define new perimeters in a very flexible way using a whole bunch of different buses, and use bow as the physical layer between the two. And so there was some discussion, can we make this spec even more useful? And there's a couple of ways of attacking this, but the first one is possibly to look at the lower level and see, can we utilize the majority of this spec and possibly move to another physical layer. And so there's a couple of things we probably want to revisit when looking at this spec, both in terms of terminology, because there's been some discussion both in terms of, is the terminology that we use the best terminology we could use? And then, either way, is there a way for us to provide additional education around how we do that terminology? Do we need another document? Do we need more diagrams? That kind of thing. Because I think there's some confusion about how you're supposed to use this spec. The other thing here is if we can make this a little more phi agnostic, or maybe not fully agnostic, provide some additional mappings, specifically UCIe, which seems to be kind of a dominant from the marketplace point of view in terms of mouths talking about it in terms of buzz and everything. Can we utilize all the work that we did with the transaction link layer spec and which still provides value and covers an area that UCIe doesn't really cover at the moment, especially not without other specs from other vendors. Could we utilize this standard that we've created and apply it to that space as well and provide some more homogenization in the chiplet ecosystem. And then is there any other changes that would make more sense to that spec to make it more useful? Go on, Ram.
Yeah, I have a quick question here. So are we trying to utilize the BOW link layer over UCI file, or a UCI link layer over a BOW file?
The BOW, the ODSA, BOW, OCE link layer over a UCIe file.
Got it. Okay. So today, the way our link layer is specified, nothing stops us from doing that, right? Because the UCI file data structure, or at the link side, no, sorry, at the file side, is very much similar to how we have arranged our bow slices. I mean, there are some extra interfaces that we may probably have to repurpose. But I see your point. I mean, basically the goal here is to see if we can somehow massage our link layer to be interoperable with either a BOW file or a UCI file.
Exactly. And your point is great. There's not actually a crazy amount of work here to make it work. You can't, if you want two vendors to be able to interoperate right now, there's a bunch of things they'd have to agree on. And I think putting some, David's favorite word was convention, putting some conventions in place so that these things would interoperate is really the goal here. So I have some examples on things we need to decide and document, but this isn't like a full other spec. My expectation is, especially if we're going to use FDI, RDI is a totally different conversation, but if you're going to use FDI, then this is really more like an appendix, and we have to probably document and diagram how that TLL to FDI interface looks, right? Byte orders and things like that, how you deal with mismatched widths and et cetera. And I have a list in just a second, but that's really all that I'm talking about for the immediate term. I think
Got it. I think the other main change, I think, I mean, I tried to look at this in my previous towards the end of my tenure there. We were looking at moving towards the UCI protocol as well. So we had the same dilemma whether to give up our PHY and build a completely new UCI PHY, or whether to use the BOW PHY and just build a link layer on top of it.
mhm.
And one of the differences that kind of is tricky to implement is the training sequences. Because from a UCI perspective, all training is governed by the transmitter, whereas the way BOW spec is defined, all training is governed by the receiver for the BOW spec.
Yeah.
So, but then I think with the way we have defined our PMR structure, I think PMR is primarily software layer, and I believe it should be fairly straightforward to swap that at the PMR level.
Yeah, I hadn't even considered the control path at this point. I think especially if we're doing FDI, that the training order and stuff is still over UCIe sideband, and so the protocol layer itself, at least in my interpretation, doesn't interact that much with that. So you don't necessarily even we don't have to deal with our control path in this scenario. We would kind of bypass that conversation. I think if we
I
go
see.
if we
Okay.
go to another layer deeper, if we do want to do an RDI mapping, which may or may not have some value here, but is a little more direct competition with UCIe. So there's also that conversation. Then I think, yeah, we would have to talk about control path changes and get really deep into the state. But from the protocol side, I think again, somebody that might have more expertise here, correct me if I'm wrong. I think the protocol is aware of the state, but does nothing with it other than, not send packets when it can't, right?
Got
So
it. I think from a protocol perspective, I mean, for our link layer, I mean, we are packetizing things in terms of granules and whatnot, but once the data structure is ready, and it gets driven into the file layer, it is more like a bit stream rather than
yes.
anything, right? So from what I mean to say is the file does not have to know exactly what bits are being passed, or interpret what bits are being passed. All the file does is do a parallel to serial conversion on one side and serial to parallel conversion on the other side. So from that perspective, I think we can still massage it. I understand the control path. I mean, the control path, if you are going to use the control path provided by the UCI sideband, then I agree with your comment on completely eliminating the control path when we use the BOW, when we use the link layer in this fashion.
Yep, that's good. Yeah. I think we're in sync on that. And like I said, if we want to do something where we do a deeper hooks, I think that we can have that conversation as well. But I think that's a longer term thing. So and I get to that point on this slide. I think there's some other things we can think about when we do this activity. At least for this proposal, I think there is an immediate need in the market, and I think Jeff would agree with me about providing some of these bus mappings to UCIe. A problem we've solved in OCE could also solve a problem in that other standards body. And so I think getting that done, like an appendix or something like that done, makes in the shorter term makes more sense than trying to do long-term things. But longer term, there's a whole bunch of interesting things I think we could look at for the layer if we have the energy for it and will from the members. There are some if it makes sense, if we think there's an ecosystem there, drawing somewhat cleaner lines and cleaner definitions between things that we do in the transaction and link layer side. Right now, they're, you know, the packet definitions are really about, you know, defining the job of who is doing framing and who's doing, you know, who's touching protocols and things like that. I think, you know, if it makes sense and we end up with, we think there's different vendors for different things, we could draw those lines a little differently in a future version. Similarly, you know, we talked about profiles and bus variants, again, a terminology that some people find confusing. And so we could either revisit the namings, or we can revisit, you know, how we do education and things like that. There's a whole bunch of other bus variants, you know, I've thought of, especially if we want to engage the RISC-V community. We can do tile link and things. Those could be side discussions, because they're, whether those end up being specs or app notes, I'm not quite sure. But either way, I think the immediate term thing would be something like actually doing a UCIe mapping. So actually, before I get into those specifics and, you know, like what I think needs to get hit, does anybody else have any comments on the goals here, at least in the immediate term?
I also think it's a great idea to align with the UCIe. That can give us a lot of benefits.
And does anybody have any? So thanks, Atai. Does anybody have any comments on like on what I'm talking about for scope for immediate term? Again, I think my proposal here is let's take a scrub through the link layer and see if there's anything that's confusing that would break in this scenario. But the primary output here would be really an appendix, just like we're doing basically an appendix or a chapter for the control path. It would be another addendum to the spec, and it would be, you know, as concise as we can make it for a transaction or link layer. Again, that's a part of the discussion about exactly what part we map, but a mapping from the existing layer scheme that we have for bus mapping to UCIe FDI. And I want to make it explicitly clear I'm talking about FDI, because I think there's a very different work scope if we need to try and do RDI or any other kind of, well, yeah, specifically RDI. I think we end up having to take on a lot of that state control and things like that.
Understand when you say UCIe FDI, are we planning to adopt the package structure defined by UCIe, or
Now
how are we going to do it?
that is part of the discussion.
Yeah,
So I think
because if you're, yeah, I mean, if you're adapting the package structure of UCIe, then basically, I mean, you're throwing away majority of the BOW link layer out.
no, okay, that's a deeper. Okay, let's go ahead. It doesn't sound like there's any objection to the scope. So let's just talk about that real quick. So the easiest mapping here is raw, right? In which you're right. There's no flit structure, right? It's just a wide bus that you're pushing across. And I agree with you, Rom. We map mostly to raw. And so when we're mapping the raw bus going into FDI is a undefined width. And so we will have, in terms of specification, we'll have to define a methodology on how to map to something. We have to, you know, we'll probably give a constraint, power of 2 or something like that, or you know, or a multiple of our you know, link layer, right? So like a multiple of 512 bits, right? You have to have something like that. But we'll provide that as a constraint going into FDI in terms of raw for a streaming protocol. And then we have to develop our convention about, because even though it's a parallel bus, as you mentioned earlier, ROM, it's really a serialized data stream. And so we have to give a convention about you know, Indianness, or, well, Indianness is probably the wrong term, but which is the oldest byte really in the data stream. And we have to make sure that whatever definition that we're getting actually maps to how it is implied in the UCIe spec, because I think it's not explicitly stated, but it's kind of implied. And so we have to make sure that we match that, because the raw bus on both sides could be different sizes, right? So if it's different, if you end up with, one side is 128 bytes and one side is 64 bytes, you have to make sure that you're not breaking implementations that, because the older bytes in terms of the serialized data stream time have to be the first ones that get mapped onto the narrower bus on the other side. And there's some conventions and stuff. And personally, I need to go do some reading too, because I don't even. David mentioned that we talked about it, and David mentioned, well, it's kind of implied, and I don't know how it's implied. So I need to go find out what that language looks like. And so there is some discussion and work that we would need to do as a group in order to make sure that we agree on how that mapping gets done. But raw is one thing, and then there are
Quick
other
question,
bus. Sorry, say again.
Between raw and RDI, there is not much difference, right?
There is. So you still do the state handling and all of that in FDI, and their star. There is still but you don't end up with there's no error checking or something like that. So we would still use our ECC and everything. Nothing would change from that perspective on our side, and we still provide value over raw. But there's a limited amount of that happens in the die-to-die adapter layer during streaming raw.
Okay.
But I think there are things that are still being handled there, and I'd have to go double check exactly what that list of features is. But that's what most people, the reason, again, another thing here is I think this is where most people are implementing these kinds of things. Most people are even if the other option here is RDI, I think people still prefer a raw FDI interface.
So when you say raw FDI, I just wanted to understand the terminologies, right? So between RDI and FDI, I believe you're adding some flow control in the mix, and then adding some logic to make sense of the bit stream that both sides can understand. Is that correct, or is it
Yes.
something different that gets added into FDI?
Well, like I said, I need to go again. It's been a while since I've read this. So I need to, like I said, I thought there was some link state stuff that happens also, but I'm not 100% sure on that. But I think for the most part, you're right, Rom. I think, yes.
Okay, that makes sense. Thanks.
Yeah, I think to be clear, we're doing FDI streaming raw, right? Not a flit format is kind of the.
Well, that's the first flavor I'm talking about, right? So
Yep.
I'd also like to bring up the possibility of picking one of the other flit formats specifically for ecosystem compatibility. So one of the other competing standards that doing kind of the same thing we're doing is Chai C2C, which is the ARM-based, AMBA standard for kind of taking over what ARM used to use multiple standards for. So if you're familiar with like ARM interconnects and the like, they used to have this version of Chai that would go through a gateway, and basically strips a couple of bits out and things like that, and makes assumptions on both sides of the gateway for fabric mapping translations. And it would go over a CXS bus, which is kind of a AXI stream like bus, right? And so that's one of the reasons when we did the bus variants and things like that, bus protocol variants, that we included CXS. So if somebody's doing an ARM-based coherent NOC to coherent NOC interface, they could provide a CXS stream over this interface, and which would then the only other mapping they standardized. You could map anything on top of CXS, but the only mapping they really standardized was Chai, and so they kind of replaced that whole stack. Yes,
Brent, isn't it that the bus to connect to the NOC or to the rest of the SOC is a layer above the link layer.
No,
So-
well, so for our link layer
Mhm.
is a link plus protocol layer. So we provide we're actually providing the actual physical bus mappings onto the packets. And so that's why this is important. So we actually provide how do you map AXI onto a translation, is it transaction? Transaction layer
the
packet,
link,
and then how
so
you map a
today-
transaction layer packet onto a link layer packet. So we provide that whole stack in our specification.
so today it's an AXI.
No, well,
So
we provide multiple. So we provide in our base specification, we provide a chai example as a profile. It's actually
Mhm.
chai plus AXI Lite, I think. And then we have these addendum specifications called bus profile variants. Sorry, is that right? Yeah, bus protocol variants. Sorry, bus protocol variants, and those are individual specs on how you can map different buses. And so there's one for AXI, there's one for AXI Stream, there's one for I want to say
But I
CXS,
guess-
and there's you could make anything. You could do a tile link version, and so
But I guess that if when someone comes to implement the design, then it makes sense to separate it in the implementation. So you'll be able to do all the link layer management and then have a different module which then sets the interface to the SOC. That's I'm talking from an implementation view, not the standard.
Kinda, yeah.
Right?
I mean, so the way the standard is written is it's all one thing right now. And the reason that we did that way is for implementation flexibility. So you all the way from the link layer to the actual bus pins, right? That's one big block from our standards point of view. We define how things are mapped internally, but it's not like it is not like UCIe where we define these hard RDI, FDI boundaries. So you can have PHY, die-to-die adapter, and protocol logic that is completely separate. We don't define those layers so that your implementation could be potentially more efficient. And I think the discussion was that we thought that the ecosystem there for actually developing those individual layer blocks was nobody's going to want to swap those out. So everybody's going to take just from one, they're just going to take a controller from a vendor, and that controller is going to have bus protocol pins on the outside like AXI, and they're not going to want to and then if they wanted a different bus protocol VIN, that's a configuration. So we figured that's the most likely implementation of these things, which is the reason for the transaction and link layer spec. We didn't bother specifying these things.
I didn't follow you. So you say that, what do you mean they'll buy from the vendor?
So I think
missed-
if you're gonna license or you're going to develop a BAU die-to-die adapter, right? Some sort of
Yes.
controller, right?
Yes.
The expectation was, whether you're developing or buying again from the IP market, would be that the native interface to the SoC would be one of these buses. So like AXI or Chai or something like that. That
Yes.
people would not be developing separate blocks to go from, link layer to protocol layer and things like that. So
Yes, but I guess as much as I know the vendors like Cadence and Synopsys, they I'm talking not I'm not talking from clear knowledge, but from estimation, is that I guess that they will do they will write their design very configurable. So you will be able to, as a customer, you'll be able to choose whether you want XI or Chai or
sure.
CX. So and
Yes.
what they will do, again I'm estimating, is that they will develop a an internal general bus and then a module which transfer it to one of these protocols.
Correct.
Oh,
So
okay.
yeah, no, I completely agree. I completely agree. So that's the reason that the transaction link layer spec was not written with these delineations that the UCIe spec has. So the UCIe spec has these mappings, right? So you can swap these things. And so and again, the reason that they do this is because they have much more complicated protocol stacks. They're having like PCIe and CXL with a lot of additional features on top of it. And so it makes sense for them to add these different additional this additional complication. And then they also provide the capability of doing muxing. So you can mux multiple FDI interfaces. And so that kind of gets to the point that I'm having here. So ARM has developed a standard for Chai C2C, their coherent bus. And the new standard, rather than having a multi-protocol stack that the old standard has, is they just provide they have a very specific FLIT format, which is a 256 byte low latency FLIT format. And they show how their bus protocol packets are mapped directly to that FLIT format. And so they give you two options, one that is that one and one that is CXL based, but we don't really care about the CXL one. And so but that's actually going to define a very specific FDI interface. Okay. And so if we want to,
and I think it's also important what you're saying is that also try to be aligned to the definition of ARM.
yes,
That's also important.
Yes. And so there's two reasons for that. One reason is because these FDI interfaces are going to exist. So you could potentially, I mean, RAW is mandated in the specification. You're supposed to have RAW, but some implementations, might be an issue. So providing another mapping to the one that ARM is pushing gives us more synergy with ARM in terms of, not conflicting with implementations that might try and do this. But it also gives you the capability of muxing this. So if you already have an existing implementation that's using Chai C2C, and you're like, you know what? I love Chai C2C for my coherent interconnect, but I really need like AXI in order to do some control paths, or I really need an AXI stream because I've got a disaggregated MMU or a disaggregated non-MSI based architecture or something like that, right? So you need AXI stream. And you'd like to put another bus over that same interface, then you get following the same standard lets you just do a mux at the FDI in the UCIe controller, and then just stick another protocol block, which is effectively our transaction and link layer attached to that FDI. And so it gives people a little more integration flexibility.
Okay.
Now that's the good news, right? So if we do both raw and we do this, then it gives us some benefits. The downside here is the mapping's a little more complicated. And David and I talked about it, and obviously there's two obvious solutions here. So we have a link layer packet, right? That is matched to our definition of what a packet size is and everything. And there's a bunch of conceits in the link layer packet header, and there's some conceits in the transaction layer packet header to this. So the two options that you have here is we can redefine the link layer packet, basically provide a new link layer packet for that FLIT interface, right? And then, and bandwidth match it. Or we can provide a methodology for mapping multiple link layer packets to that new FLIT format. You have the same problem either way in terms of you're going to have to provide, because we don't currently have a way of mapping multiple transaction layer packets to a link layer packet in our system. So if you redefine you kind of move the problem up the stack. If you redefine the link layer packet, then you have to provide a methodology for mapping multiple transaction layer packets to a single link layer packet. And then because right now I think there's a limit of 1. And then the other problem that you run into is that you end up with some redundant features and inefficiencies, in either case. And so, and specifically on that is that our ECC is packed into the transaction layer packet, right, along with the protocol flit. And so, but if you're going over a flit-based format in UCIe, there's already CRC and flow control and stuff. So ECC is somewhat redundant, depending on your point of view. So
What?
Go
Sorry,
ahead.
just very quick with regards to ECC. I think the way that we defined it, we made it optional.
that was in the
Right.
control path.
Yeah,
It's
yeah.
not, it's
Yes, yes.
this is the link, this is the main
Yeah,
band link
yeah,
layer.
yeah, 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 yeah.
So, but Helia, to your point, that is an option for us as well. We could make it optional here too, if you're doing that. But I think if we're really looking at what is our lowest bar in terms of a specification, we want to get something out, and what makes the most sense. And again, like I said, David and I talked about this, so I'm gonna throw this out here, and I'd like people to give it some thought. In the in between meetings. I think the lowest bar of entry is just do the same thing that we would be doing for a raw interface for the FLIT interface, and just provide some conventions on how link layer packets are mapped to the FLIT format. And any inefficiencies that you incur in that, which include ECC, we just eat it for now. We just say, all right, this is a standardized way of doing this mapping. You're going to end up with a little bandwidth inefficiency and little power inefficiency, but this gives you a way of getting this across the link. Elia, did you have a question?
Yes. So, do we need to, as a low bar, I like how you trying to stage it. Do we need to support both raw interface and flit interface? Can we start with one and then move to the other? Or now that we are opening the door, maybe we can support both.
Yeah, I think I think you could just do raw. I would prefer to do both because I think it might entice ARM to be more cooperative with us doing this specification. And it might, because one of the problems I had with our previous specification is we defined a whole bunch of AMBA mappings, and ARM gave us kind of a wiggly thumbs up saying, you're free to do that, but they didn't give us any time in terms of actually putting their eyes on it. I think if we are more friendly to coexisting with their standard, they might be a little more amenable to, validating the work that we're doing here in terms of bus protocol mappings.
So I think there is an alternative, right? Because we could just do raw and then have a C2C mapping in the protocol variants. And I mean, it seems like that should be feasible, right? Because the C2C protocol is going to be active in an SOC at some point. There's going to be an interface defined there, clean interface.
Yeah, we can do that as well. I think we'd want to do that either way, right? Because I think there's some additional questions here about where you do muxing, right? Are you muxing at FDI? Are you muxing at the protocol layer? And technically, we kind of support both right now, but I think there's some stack implications and interoperability implications of where you do it. So I would say, regardless of what we do with the FLIT format, I would also want to do a chai C2C bus protocol variant mapping as well.
But so wouldn't that be the lowest bar that we just kind of lead
Well,
with?
again, it depends on what the ecosystem looks like from a hardware point of view, right? So I think this is really less about, this is about, you know, again, if I don't know what ARM is shipping, right? But if they're shipping this hardware already and they're like, I don't want people swapping out the controller, right? Or I don't want people swapping out our protocol layers, then, you know, having them provide a MUX on the FDI is a lot lower bar. So having this, I don't think this mapping costs us a lot, other than if you're willing to eat the inefficiencies.
Okay, and we're also basing the need to do this because we think that there might be muxing issues between raw and this flip format, the 256 byte flip format.
Yes. Well, that is somewhat, I think, UCIe spec dependent, which
Yeah.
version you're implementing. Because I think David was saying like 1.0 for sure has issues with that. 1.1 has fewer. 2.0 may have even fewer. But you know, but I don't know what people are using. I don't know what people have already in flight or whatever, and I don't know what the ecosystem is really pushing. So maybe then again, this is a deferred conversation for actually making a decision here. Maybe people need to go through surveys about like what they're thinking here. But I'm just saying, if we want the maximum footprint for this, then it makes sense to also have have a flip format in addition to raw.
Okay, but I think we should kind of figure out, is there a muxing issue before?
There for sure is a muxing issue if you're talking about 1.0. And there is a tentative muxing issue, I think, in 1.1. And then I think there's less of one in 2.0. But again, I don't remember the exact limitations you have on muxing in 2.0.
Yeah.
Guys, I have to actually drop, but before I do, I just wanted to ask, like, in the last meeting, when Brian presented, it seemed like Ventana has something implemented. I'm not sure how much they're willing to share, but could we have some discussion around that in the next meeting?
Yeah, potentially. I think we're very much aligned with what Brian is proposing, so it's going to be in line with what our approach was, which was
Okay, perfect.
yeah, mapping to FDI raw, streaming raw.
I think, like I said, I think the majority of the documentation here is really about just adding some additional clarifications around how those on the physical pins, basically, right? On what the conventions are for the physical pins. So again, if Ventana has those already and we can all validate that those are good, then it's a very simple exercise for us to convert that into something that is integratable in the specification.
Yeah, let me take an action to see what we can bring to the next meeting then.
Yeah.
Yeah, so kind of trying to wrap up this great discussion. We have 5 minutes left. You ask about immediate at the beginning. What can we do immediately, and maybe with respect to the control path? It seems that we could potentially define something as a low bar entry point. But nonetheless, it requires some massaging and some clarification, and could potentially need maybe some input from ARM or some input from UCIe. So from the process perspective, I'm thinking that could potentially take some time. What are people's thoughts here to ship the control path as v2.0 while we continue working on these thoughts?
I think that's fine. You know, I don't honestly don't know how long it's going to take us to get through conversations here on the link layer. So then there's no reason to hold up the control path. But you know, if we end up getting a bunch of comments back on the control path and it takes us a while to absorb those, these things might catch up. But I don't think there's any reason to stop pushing forward on the control path.
Okay, so that's great. So if tomorrow, tomorrow, are you going to share the status on the OCE?
Oh yeah, sure. Yeah, I'll talk about that on. I'll come to the call tomorrow and talk about it. Yeah.
Yeah, and if bring that the control path is ready to everybody's attention, if anybody wants to review the quote unquote informal version spec, they can pass it along while we are working on the formatting. That would be great too. Thank you.
Yes, thank you. Yes. Anything anybody want to bring up on the link on the proposal here that before we close? Okay. Yeah, so Jeff, if you can just by the next meeting tell us what you think you have, and then we can start
Yeah.
depending on what you guys are willing to share. I guess we'll define kind of what the work is needed for the group and how we scope things out going forward.
Okay. Sounds good.
A logistic question: are people around next week? I'm traveling and I'm not around, but if people are around, we can continue to have the meeting.
Oh, that actually brings up a good question. So I'm around next week, but I'll be out the week after, and I have a bunch of travel possibly coming up in the next couple of months. So and from an editor point of view, it might make sense for someone else to kind of pick that up because I might end up having to miss meetings because I'll be on planes and stuff like that. Happy to contribute though, but if somebody wants to pick up the actual editor part, that would be fine with me.
Okay, let's see if somebody volunteers next
dead,
week.
dead silence, dead silence, as always. So just yeah, so FYI on that.
Okay, please bring it up next week too. Thank you.
Okay.
Okay, bye bye everyone.
Thanks.
Thank you.
Bye.
Bye bye.